Hi, my name is Amelia Renault, and this is my learning log for Math 3050. On the inside, I have my learning log rules as well as my title page. And in the very back, I have my note to the teacher. This is my table of contents, and we're going to start off with measurement, which is on page 16. So I'm going to go over to page 16. This is where the second half of the semester starts. Okay, on measurements, we start out with non-standard units and metric measures, and I just listed different types. Like for instance, a non-standard unit would be pencils, feet, paper clips. These are just different examples I have. And then over here I have a little sticky note. This helps me remember how many feet are in a yard, how many inches are in a foot, and how many feet and yards are in a mile. And then below I have my answers. This is a continuation of measurement. These are benchmarks for standard units, which helps me remember that the width of your thumb is 1 inch, which this helped me with my final exam. And this also begins to start to talk about capacity, such as how many quarts and pints are in a gallon and so forth. Over here I have two sticky notes with the metric system. This has the name and the unit measure, and then below I have the different amounts that they have. Continuing on, this is more with measurement. This just tells you how to convert temps, such as from Fahrenheit to Celsius. And over here I have an example problem, how to convert Fahrenheit to Celsius of 94 degrees. And below I have how to work it, which we subtract 30 and divide by 2 to give us 32 degrees Celsius. Moving on, we have similarity, and I have the definition here. Similar objects are the same shape but not necessarily the same size, and that helps me remember for my test. For example, rectangles, although they are the same shape, they're not necessarily the same size, which they are not similar because their ratios are different. This is more similarities. This is similar triangles, for example. Here's a problem with a tree that casts a shadow of 40 meters and a person or a meter stick that casts a shadow of 2.5 meters. And we set it up like a problem and we solve for x to get 16 meters, and that's how tall the tree is. Over here I have a similar problem and I have it solved on the inside just to help me remember how to work it. Moving on, I have the congruence and the Pythagorean theorem. This I struggled with on my final exam because I could not remember how to do this, but I know the Pythagorean theorem is a squared plus b squared equals c squared, and that rule applies to any amounts that you plug in, as well as the triangle inequality. If you have two sides, they must be greater than the third side. If it's less than or equal to, then it will not make a triangle. Moving on, this is more congruence in the Pythagorean theorem. It's just more properties such as angle, side, angle. It's a continuation on from the page before. This is again just continuing on congruence in the Pythagorean theorem. This is an example here of how to solve a problem using the Pythagorean theorem. This gives you the amounts that we would plug in, and then once you plug in you would solve, and then you would take the square root and get your answer. Here we have perimeter and circumference. It's kind of small just because I'm pretty familiar with perimeter. I have an example here. It's what is the perimeter, and basically you add all of your sides up and you get your answer, which is relatively the same for all of them. Some are slightly different, but most of them follow that same base. This is moving on to area formulas. I have each one highlighted to help me remember. Over here I have the formulas for each, and then below I have the name of that. For example, a length times width would be a rectangle, and if you multiply the base times the height, or the length times the width, that'll give you the area for that. This is geoboard areas and Pick's theorem. This is one of my favorites. It's the Pick's theorem. It's basically the area of a polygon on a geoboard can be calculated using this formula. It's A, which is the area, equals half of the boundary points plus the linear points minus 1. And the boundary points are all of the points on the outside, and the linear points are the ones on the inside. So, for example, there's 6 points on the outside, so 1/2 times 6 plus 4, which there's 4 points on the interior, or the linear points, minus 1. And then we solve and we get the area is 6 for this problem. And I have an example problem up here as well. What is the area? We would add 1, 2, 3, 4, 5, 6, 7, 8, and then we would plug them in 1/2 times 8, and then there's 2 linear points, so we would plug those in and then solve to get 7, and that's just a helpful way for me to remember that. This is a model for constant area and perimeter, and similarity effects on perimeter area. This is particularly about the banquet tables and the square tiles. This one I found the best way to figure out the arrangements is to factor out the number. So say the table asks for like for instance over here, for 20 people, what would be the area and the perimeter? Well, the perimeter is always how many people that are seated. So since we know it's for 20 people, we know the perimeter is 20. And the area is how many tables. So then you would just simply count the amount of tables to get your area, which I put those underneath as answers. This is surface area. This is just plain definitions on this page. It starts out with surface area equals lateral area plus 2 base areas. And this is an example for a rectangular prism. The lateral area is you multiply or you add both the base twice because it's 4. So it would be, you would add it twice. And then you would multiply it times the height to give you 64.4. Then you take the area of both bases, and then you multiply it, and then you add it to your lateral area total to give you 105.1 millimeters squared. And then I have this is how do you find surface area, and this is just an example, the answer of how to find surface area, of how you take the lateral area and the base area and you add the totals together. This is some more surface area, and it started to get a little confusing with all of the different types. So I made a pocket, and this has each type of surface area that we discussed in the class for triangular prism, pyramid, cylinders, cone. Those are just helpful ones to help me remember because it's a little difficult remembering all of the formulas for each. This is more surface area. This is cylinders and cones, and I have an application problem here. And I have each highlighted, like cone equals pi r squared plus pi r times the length, and then I have it solved here. You would just plug in from 12 centimeters and 8 centimeters as from this example. This is volume. This is each volume of a prism, triangular prism, cylinder, pyramid, cone, and sphere, and all of the different formulas for each. It's difficult for me to remember the formulas for every one, so I created this foldable. It have the volume formulas for a cube, and then I open it, and it has length times width times height, which is how you get the volume of a cube, and then a prism, and so on and so forth. Those are all labeled. building views. This is probably my favorite thing that we learned all semester. I found it to be really interesting because you can take a flat mat or foundation mat, I guess is what you would call it, which is essentially the top view of the building. And you would take, for example, if you wanted to look at it from the right side, you would take the tallest point, which would be 3, and you would draw it down here in the 3. And then you would look at the next one, the tallest point is 2, and then you would draw 2 in the middle. And then we don't have anything taller than a 1 there, so the 1 would go there. And each is the tallest form. That's how I know, even from the front view, they're all of the same. They all follow the same kind of pattern. And then down here is an example of an isometric drawing. It's not really the best example, but I have the foundation mat, the front view, the right view, and the left view, which I love because they're mirror images of themselves. And over here I have an example of the right view of a mat, and then I asked what is the left view, and I know that it's a mirror image, so it would be nearly identical, just flipped around. And this is my learning log for Math 3050. That is the end of the course. Thank you.